Right, we continue with the chapter on BJT amplifiers. Today we do the common base amplifier. And as we always do, let's have a look at the introductory paragraph in the textbook as displayed on the board there. Underline or mark. The common base amplifier provides high voltage gain with a maximum current gain of 1. Since it has a low input resistance, the common base amplifier is most appropriate type for certain applications where the sources tend to have very low resistance outputs. Now recall the previous amplifier that we've discussed. One of these parameters were also equal to 1. Which one was it? Voltage gain. Now in this case now for the common base it is the current gain. Alright, the current gain. But anyway, let's have a look at the amplifier circuit. First, we have to be able to recognize the configuration of amplifier. Okay, the way that I taught you with the previous ones that we've discussed, I have to go and look. Where's the input applied? Not like that. Where's the input applied? There's my input signal. I can see it's applied at the emitter in this case. Input is applied at the emitter, output is taken at the collector. So you can see there's my output waveform, and I can also see that the output and input waveforms at this stage is not out of phase. They are in phase. But anyway, the configuration of amplifier I can see then via this capacitor that acts as a short for AC. So the base is AC, grounded, makes this a common base amplifier. Alright, you always have to first, if you look at an amplifier, but of course they're not going to tell you when you get the circuit to do all your calculations or whatever, what type of amplifier it is, or not always. You have to be able to recognize the configuration of amplifier. Okay, so in this case we can see it is a common base amplifier. Alright, if we get back to the textbook, I haven't got enough space to move it, so I'm going to make it a bit smaller. There you can see at the bottom of the page voltage gain. Voltage gain always V out over V in. In this case it is VC over VE. Output at the collector, input at the emitter. And then by substitution I can see that it is IERC for VC, and for VE it is IE in brackets R X and E in parallel with RE. We turn the page. We've also seen a rule of thumb. If RE is much smaller than RX and E, this simplifies down to voltage gain of RC divided by RX and E, where I know of course that R lowercase c is RC, the resistance at the collector in parallel with the load resistance, RC in parallel with RL. And you will also note again that the gain expression is the same as for the common emitter amplifier that we have discussed previously. However, please underline, there is no phase inversion from the emitter to the collector, because the input is at the emitter and the output is at the collector. There's not going to be a phase inversion. Alright, the input resistance. Looking in at the emitter, VR in at the emitter is VE over IE. By substitution, I can see then IE in brackets RX and D in parallel with RE divided by IE. And cancellation, and also I know that RE, and usually this is true, is much larger than RX and E. R in at the emitter is going to be equal to RX and E, seeing that the input is at the emitter as we've seen on the circuit diagram. Alright, the output resistance, looking into the collector, the internal or the AC emitter or AC collector resistance appears in parallel with RC, as we've seen previously with the common emitter amplifier again. And what do we know about RX and C? Very large, very large resistance. And if it's in parallel with RC, we can assume that R out is then just equal to RC, because I know two resistances in parallel and the one is much larger than the other, then it will normally be a little bit less than the smallest resistor, which is RC in this case. So R X and C is much larger. So R out is equal to or equivalent to RC. The current gain, we've read in the introductory paragraph, is approximately equal to 1, because we have seen right from the beginning, since we've discussed transistors, that IE and IC are approximately equal. They only differ by the value of IB, which IE is the largest, which is IC plus IB, but IB is very small in comparison, so I can assume that IC and IE are equal or almost equal, and I can make the assumption, like in equation 621, that the current gain is approximately 1. It will always be less than 1, of course, but it will be close to 1. The same as we've had with the voltage gain of the common collector amplifier. So thus the same then as for the common collector amplifier, where the voltage gain was equal to the current gain, because the voltage gain was approximately 1. In this case, the power gain will be equal to or equivalent to the voltage gain, seeing that the current gain is approximately 1. Alright, so those are the parameters for the common base amplifier. So as you can see, very important, firstly I have to be able to recognize the configuration of amplifier. Why? Let's have a look at the example on the next page. Let's read the question there. Example 611. Question asks, find the input resistance, the voltage gain, current gain, and the power gain for the amplifier in fig 632. Doesn't tell you what amplifier. So if you're not able to recognize if this is a common emitter, a common collector, or a common base amplifier, then you won't be able to do the calculations. You're going to see that, né? So you have to be able to recognize the configuration of amplifier. Then of course you also have to know the characteristics of that amplifier. Alright, and they also give us the value of beta DC, which is 250. Alright, if I go and then I can look at the amplifier, and I will see that input is applied at the emitter, the output is taken from the collector, so the base is AC grounded, making this a common base amplifier, né? So then I can calculate accordingly. If I go and look at the solution, first find IE so that you can determine R accent E. I have to know R accent E, and be able to determine R accent E, I have to know the value of IE, the DC value. Alright, and since beta DC times RE is much larger than R2, I can assume that this amplifier is stiff. Then I can calculate VB, and of course VE, and finally IE, as you can see there. Once I've got the value of IE, then of course I can calculate R in, which is also R accent E in this specific amplifier's case. 25 millivolts divided by the IE, in this case 23.6 ohms, a bit higher than I said it would normally be, but you can still see it's a very low resistance. Alright, so once I've got that, I have to calculate R lowercase c, which I know is RC in parallel with RL, because I can also see in this circuit that there is a load resistor. Alright, remember I told you, don't go and learn these equations by heart. You have to go and look at the amplifier that you work with, so that you know you have to include in your calculations. Okay, so once I've calculated RC, I can then use the voltage gain formula. It's then the RC that I've just calculated divided by R accent E, gives me 76.3. Remember, there's no unit, it's just a ratio. A lot of students, because it says voltage gain, they want to write the unit V behind that says volts. If you write that, 0, hasn't got the unit. Alright, then we know that the current gain for this type of amplifier is approximately 1. Thus, the power gain will be equal to the voltage gain that we've just calculated. All right, everybody happy? Okay. So, if I go back to the other screen here, there's the problem that we've just done. So it's the end of this specific section. So the same rules apply as for all the sections. Just lastly, note that the problem's now escalated up to 28. So you have to do 26 to 28 as well for this specific section. And please go and do them, but do as I instruct you here to do it. And if you do have problems with solving the problems, go back to the section, go and read through. Maybe you missed something, have a look at the video again, and then try the problem again. If you still can't do it, leave a space open in your homework book. When we get together to discuss the problems, then you can fill it in again for revision purposes for tests and the exams. All right.